Hello, everyone. Welcome to a SQL live practice session. And in this session, we will be together with AI students as well. And my name is Yasin Anıl, and I am the instructor of this SQL course. And we will do a quick review on SQL, and we will also review some important parts on SQL. Okay, let us start. Dear friends, SQL stands for Structured Query Language. We will store some data for the applications, just like this one. Let me explain. Over here, this is our application. You can go to this application that I shared on Slack. Just go to this application and you will see when I sign into this application, you will see, I will see some, over here, I am going to see some data like pictures, text, whatever web element you see here, there are some data. So we get this data from database, okay? Even if I sign out and sign in again, they will be there, okay? For example, if I add something into my cart, I will add this. I will add this one as well. So I have these two products in my cart. This data, it is saved in database for me, okay, for this user. Even if I log out, even if I close the windows, all right, I will get it one more time, okay? I will go to the application, bazaarstore.com. I will log in one more time. All right, you see it is still there. So how does it happen? I add them into cart and they will be saved in database. Okay, they will be saved in database. And even if I sign out and over here close the window and sign in one more time, they will be there. Okay, so where are they? They are in database. In structured query language, for example, we have a table for this user. For example, for this user, it is going to have some data in the cart. For the cart, there will be some data. And for favorites, there will be some data. For example, for some products, etc., they will be saved. Then there might be some other tables for this user. They can have relation between them. I will explain them. So as you see over here, we have this data in database. Okay, when I view the card and if I confirm it, okay, so it will be saved. That is 0. If I sign out and sign in one more time, you will see I will not have this data. As you see, it is going to be saved in database. I will send some queries to get the data again. I will get it. Okay, dear friends, go to this application, please. And then please sign up. Go to this application and sign up, please. Okay, for over here, when you do sign up, it is going to ask you to enter email, name and surname, password, and confirm password one more time. Please do this. I want to add here abc@abc.com. And the name will be John Doe. The password will be john.123. I will confirm it as john.123 and I will sign up. When I sign up, okay, you see we have the success message here when I sign up. So that abc@abc.com, the John Doe, it must be saved in database. Okay. So I will go to database now and see it. I will open the PG admin. Let me open the PG admin and I will connect to database for this application. I have some credentials. I have some credentials for this application. You will see then over here we have the servers. I have these two servers. For PostgreSQL, for my local database, I have this. And for Bazaar Store, over here, I have this server. You see, under this server, we have for the QAs, this one for the testing place. I will open this. Okay. And then under schemas, under tables, we have these. We have here these tables. So what did I create? What did I create? I created a user, right? Because I registered. That must be saved here in this table. I will open, I will view all rows. You'll see John Doe is here. Okay. John Doe at abc@abc.com. It is here. If you register here, and any user, I can see it. Just like this one, I will sign up. I will create one more user, like over here. What is that? John Doe at novatechacademy.com. And the name will be again John Novatech, I will say. John Novatech. And this is going to be just a password 1, 2, 3, 4. If it accepted that password, I will just check. The password field must be at least 6 characters. Let us say again 1, 2, 3, 4, 5, 6. I will try 1, 2, 3, 4, 5, 6. I will sign up. Yes, required field. The name field is required. Yes, let us John Novatech. And 1, 2, 3, 4, 5, 6. This email, yeah, we have that email. John Novatech. I will create a password. Okay, john@novatech.com. John Novatech. I will say this. I will create this user. Yes, it is success. So I will go to this database. I'm going to view all rows. All right, John Novatech is here. Okay. Whatever I do here as actions that will be, I will sign in as customer. Okay, I will sign in as customer. For example, I want to add something to cart. I will add the laptop. I will add the e-book reader. I will add the jeans. Okay, I have these 3. So when I log out, log in one more time, they are still here because they are in database. Okay, these users cart items. Okay, so if I go to database, over here we have these tables. For example, for these products, favorite cart we have here. Whatever we have in cart, it must be saved here. I will see this cart table. You will see for this user 3, this ID, for these users, we have product 1, 8, and 9. You see, they are saved there. If I delete these products from that cart, they must be deleted from here as well. Okay, I'll go to my application. I'll view the cart and confirm the cart. There is no, over here in my cart, there is no product. Then I will come here. If I see this cart one more time, as you see, cart is empty. There is no product in cart. Okay, this is database. So we will manipulate these. We will manipulate this database ourselves. Okay, in users, we created users and we see them. Okay. And also I just added some product in cart. It's gonna be saved. If I add something favorites, okay, favorites will be saved here as well. So the data will be constant. Let me close this. Okay, so we save some data, right? If you have any question up to this point, please do not hesitate to ask. Now, we have data. So with structured query language, they are going to be saved in database. So with this SQL, we will manipulate it. We will create those tables. We will manipulate those tables. All right. So we have some commands to do these manipulations. Like what? Mostly, we have data definition language. Data definition, data manipulation, data control, transaction control, data query. Okay. Data definition means, dear friends, data definition means when you define the data, dear friends, this is the data itself. Let me show you the users. Let us see. This is the data itself. You see this part. These are users, the data itself. So data definition is the data about the data. What is it? These data's table. It is data definition. Columns, column names, data types, its size, they are all data definition. When you create a table, it is data definition language. When you update a table means updating the column numbers, column names, column data types, adding a new column, deleting the column. They are all data definition, not the data itself. When you create a new data, for example, when I create a new user or when I add something new in the shopping cart, they are the data itself. But if I change some column, if I change some data type in this column, it will be data definition. I do not create a new data or update or delete it. That is the data definition and the difference between data definition and data manipulation language. Data definition means metadata. Metadata means the data about the data. The data itself, we have the rows, the records, but the columns, but the tables, data types, size, those are all data definition. But when I add a new row, like adding a new user, like adding a new product to the cart, or like adding a new favorite or deleting them, adding a new data, updating the existing data or deleting existing data, that will be data manipulation language. All right? Data definition means the data about the data. And when you add a real data, the data itself, update or delete it, that will be data manipulation. Data control means who can access this data. That is the DCL, data control language. Means you will do grant. Grant means you will give some access. All right, you will give some access to the users. What can this user do in this database? This user can only read. This user, dear friends, I will give you these credentials. I will give you these credentials. You will be able to access this database as well. But this user is just read only. That means it can only read the data. I cannot delete any of these tables. I cannot add here a new table. Okay, I can just read here. For example, if I want to update this column, the user update column, and I will say update these users, then I will say, for example, change this name. I cannot do it. I can just read it. This is read only. That means I have only the reading authority here. It is the grant. If you, for example, if the admin will revoke, that means it will get the authority, so it will be revoked. This is the data control. Who can access? What can they do on database? It is data control. This data transaction means you did some actions, then you want to save that part. For example, in this version you have, this part you have. So you are going to do some changes on this. For example, you will add this part. Okay, if you want to go back to this previous version, you can commit it into this point and add something new. If you go back, if you can save it, they are going to be data here transaction control. Okay, transaction control. And we have also data query language. You can also put this data query language in data manipulation because you read the data itself. For example, you will get some rows. This is data query. This is select. You will just use select over here, just like we did. All right. Select all from users, it says. When I run this, it will give me this data, the ones I created. Okay. You see, we have data definition, data manipulation, data control, transaction control, data query. These are all SQL commands. We have some data types, numeric data types. We have these are numeric data types. These are some string data types. We have date data types, Boolean or binary large objects. Okay, binary large objects like images, like videos, etc. These are binary objects. Okay. Relational database management means, they have relation between them, and we will use these management system. Okay, there are many management systems like MySQL, PostgreSQL. These are some common ones. We will use PostgreSQL. Let us start with PostgreSQL. It's an open source relational database management system. We will install it first, the PG admin on our system. Okay, we will add this PostgreSQL. After this installation, we are going to use these definitions, like, for example, creating a table. When you create a new table, so you can also add this. First, when we create the table, we need to declare its here column names and also its data types. What is the name? It is employee ID. What is its data type? We need to declare it. What is the column name? It is name. It is going to be varchar or integer or varchar one more time or another numeric data type, data definition. With create, alter, drop, and truncate, we just create a table, change it, delete it, or delete the rows. You see, this is not directly related to the data itself. They are related to data about the data, the metadata. But this truncate, we can consider this as data manipulation, but it will remove all the rows from the table. But we can say also this truncate as data manipulation because it deletes the data itself, not the table. Okay, you see, create table we have, create table. We will create some table like this keyword. When you create the table, you will say the employee ID. This is the column name. Column data type will be this. You will declare them first, and then we will add something into this table. What is that? For example, we will do it in data manipulation, but for data definition, we create table, we change table, alter table, add column. So then we can change that column's data type, or rename the column, or drop the column, add foreign key. We will explain what is this. And we can also, manipulate the constraints. But we do not touch here the data itself. If you do not touch the data itself, if you just touch the data about the data, the metadata, it will be data manipulation. I mean data definition language, drop and truncate. We do not touch the data itself. We just touch the data table. Data manipulation. Dear friends, in data manipulation, as I told you before, if we touch the data itself like this one, for example, I want to add a new user, or I want to change it, it will be data manipulation language. Add a new row, update it, delete it, or read it, they will be data manipulation. Just like we did here, I will insert into employees this value. All right, the ID will be 1, name will be Alice, position will be manager, and salary will be 70,000. All right, so you can insert multiple. In this way you can do it. And also you can insert without declaring the column names. In the column orders, they will be inserted. First column, second column, third column, and the fourth column, it will be inserted in this way. Okay, you can update the employee tables, set the salary to this. If you do not use where clause, it will update all the salaries to 70,000. But if you use here just like if clause, you will use where the employee ID is for. If the employee ID is for, set the salary to 70,000. This is just like a simple English sentence syntax. You will understand it, whatever it says. It is just simple English. Update employees table, set the salary to 70,000. If the employee is for, where the employee is for, change it. You see? Then you can also use to read. Just give me the employees, all the columns, if the position is developer. If the name is Eva, then make the position designer. All right, you can see it from here. Again, delete the row, delete the record if employee ID is 4. Everything will be deleted about this employee ID 4. You cannot delete the specific cell. You will delete the whole row. Okay, the row itself. Not all of the rows, just this row, just this record. If you do not declare where, it will delete everything. You need to be careful about this when you delete data. Okay, you can also use is null. If it is null, if the position is null, delete it. You see, is null is the condition used to check if column's value is null. Okay, select is just for reading. You see, I will get over here, select all. This asterisk, this star means give me all the columns. This one, and this one in this order. But if I say give me first name, so in the query, when I want to see in the query, first column will be name, second column will be salary. from employees. Just name and salary I will see. This one and this one I will see, not this employee ID and position. These two will be seen after this query. Okay, let's see the constraints. Let us talk about this. Dear friends, constraint means the rules about the rules about these columns, we can say. Inserting or deleting or updating, there will be some rules. What kind of rules are they? These are this kind of rules. Okay, let's see. First, it says primary key. Dear friends, I have this table, and in this table, if I make this one primary key, first one, you cannot insert here for the null and duplicate. For example, if I give here 1, you cannot give one more time 1 if the primary key is this one. So it must be unique and not null. Unique and not null means it will be just like a primary key, but you can have only one primary key in one single table. There will be also some combination for this. We will explain that. So you will get two primary key. For example, you will get two columns as primary key, but they will be one single primary key. Okay, I will explain what is that. It will be composite key. Foreign key. Okay, mostly this foreign key is confused. Let me explain what is that. Dear friends, this one, I will explain it. Let me let me explain. Okay, in this way. Over here, I have this table. Over here, I have this table. Here I have a table. You know, in this table, I have some rows like this one. This is A, this is B, this is C. All right, it's going to be ID or anything, X, Y, Z, and A columns. For A, I will get multiple. For example, for A will be multiple telephone numbers. Okay, but we are going to ask user to enter phone numbers. This is going to add 5 numbers, or this is going to add only 1 number. This is going to add 2 numbers. For this kind of issues, am I going to add here 1, 2, 3, 4, number 1, number 2, telephone number 5? No, I will not do that because it will be memory consuming. For example, just imagine here 1,000,000 of data. So just in million data, maybe just 5 or 6 or 10 people will have 5 numbers, but mostly people will have 1 number. But for this kind of issues, for example, other millions of rows will have a null, second number, will have null a third number or fourth number. It will be a memory consuming. So what should we do this kind of issues? We will create a foreign key for just telephone numbers. I will say for A, telephone number is this. For A, one more telephone number is this. For B, telephone number is just 1. For C, telephone number is this. But for D, we will have 5 numbers. You see here? D, D, and D, and D. We will have for the 5 numbers. So what does it mean? It means there is no null cell. So for this kind of issues, to get rid of these memory consuming, so I cannot add here something doesn't exist For example, A, B, C, we have D. This is the rule in foreign key. Okay, this is gonna be, this column will be our foreign key. This column will be foreign key. In this foreign key, there must be a reference. The reference will be this column. Why? It means if this A doesn't exist in this parent table, you cannot add here that A. For example, I cannot add here Z because there is no Z here. So this foreign key will create relation between them. This is the main reason to use foreign key. It can be null. You can use null, but you cannot use non-existing data here. All right. If you get here D, you can add D. If you do not have here E, you cannot add here E. This is the foreign key. By doing some practices, you can understand it better. Okay, foreign key. This is important. Mostly it is used to create relation between two tables. We use foreign key. Okay, the unique means you cannot add one more same column. That means all the values unique. Not null means you have to add something there. You cannot leave it blank or you cannot assign null. So check means you can add here some your own rule. That means, for example, when you want to add here in age column, into this age column, you will put a rule. That rule will be the age must be greater than 18. The age must be between 18 and 65. Otherwise, you cannot add the age. Otherwise, you cannot add that record here. You can put your own rule with check constraint. Check. Check means the custom constraint. You will add your own rule. Serial means you will not assign anything for serial. For example, for the ID, mostly it is used for ID. When I add a new record, I will just add name and telephone, for example. But the ID will be added here. The ID will be added. Automatically generates a unique incrementing value. First one will be 1, second one will be 2, other one will be 4. Okay, 3, 4. Just like over here, you see, when I create a new user, I do not assign any ID to that user. It is assigning itself. This is serial. You see, this is serial. It is going to add this ID as 17. This is going to be as a 19. If I create here one more user like this, it's going to be 19. Let me add here one more user. I will sign up. Okay, so I will use here check constraint. I will say check. The name will be check. I will add, let me put it. Okay, then I will sign up. I will sign up. Yes, it was created. All right. Now, when I send the query one more time, yes, I see that check here as 19. It will be incrementing in this order. You see, it says automatically generates a unique incrementing value for each new row, often used for ID columns. All right, mostly for IDs it's used. This is serial. Default means if you, for example, default will be this one. For example, if I do not enter any name, it will add here the name itself, like no name, or please add any name or something, you can see it. we have some here for the roles. For example, I create customers. Okay, this is default. Why? Because when I create a new user here, it will create it as customer. You see, they are all customers because it's not gonna be admin or store management. Okay, we talked about primary key. Composite key is this one. Dear friends, over here you see species and name. These two will be primary key. These two. What does it mean? Dear friends, you can assign primary key for these two columns, but it will be composite primary key. That means this must be unique. You can add one more tiger here, but you cannot add tiger Cheryl. You can add here, for example, for tiger. Okay, if I want to add here tiger one more time, tiger, yes, I can add here tiger, but I can not add Cheryl here because it exists. But if I want to add here tiger paw, I can add it because there is no tiger paw here. We have paw here, yes, but no tiger paw. This is the composite key. This is the composite key. You see, each pairs must be unique. This pair, each pairs must be unique in composite primary key. Okay, as I told you, this is the foreign key. You see, for these users, if I want to add here the order, okay, for example, John Smith has more than one order. Okay, I will not add here order 1, order 2, order 3, order 5. I don't know how many order they are going to give. It will be memory consuming. Because of this, I will create a foreign key as customer ID. This is going to be primary key. All right. If 1 doesn't exist here, you cannot add. I can add 3. I cannot add here 4 because there is no for customer ID. I cannot add order for 4 because there is no customer such as 4. This is the relation between them. But it can be null, all right? Without customer, you can add order, but you cannot add non-existing user. It must exist here. The unique, what is the unique? Dear friends, unique constraint in SQL ensures that in each row, if I declare any row as unique, you see here, if I declare any row as unique, you see, if I declare this one as unique, when I add here 1, I cannot add one more 1. But I can add 1 null. I cannot add 1 more null. I can add only 1 single null here. This is the unique. Not null means you cannot add any null. Okay, if I make this one as null, for example, this T, let's say, not null means I cannot assign here null. Every single column for every single rows for this column must be assigned. You cannot assign null. As check, as I told you, you cannot. You will put check constraint between 18 and 65. You will put you will put here. Okay, let me. All right. You will put a custom rule, your own rule. You can say, for example, if the worker name starts with A, okay, you can use it, or you cannot assign here with the name length is greater than 10. Okay, you can put some rules here. Serial, as I told you, When I create, when I add Turkey, United States, Canada, I can add them, but these country IDs will be added automatically in this increment. Incrementally, it will be automatically generate unique incrementing integers. Okay, default means this. For example, if I do not assign anything, it will assign itself as default. It will assign here default itself. Okay, there are some on-delayed. For example, I have over here. I have over here parent and child tables. For example, as author ID, I will create a relation between these two. All right. So, for example, if I use over here the cascade like on delete cascade, deletes all the related rows in the child table when the parent row is deleted. Means if I delete this author ID one, it will also delete this row from child table. This is the cascade. Set null means if I set instead of cascade, if I set null, it will set null for these values here. It will not be deleted. The row will not be deleted. Then it will set null. Set default means if I declare set default as, for example, not found, they will assign here not found, etc. They are going to assign here a default value. No action means instead of cascade, if I add no action, prevents the deletion of the parent row if there are related rows in child table. So you cannot delete from here the author ID 1, because if we have here 1, you cannot delete it. Okay. These two are same, restrict and no action. If we have a relation between them, you cannot delete parent, but you can delete child. Because over here, a child is connected to parent, you can delete child. Okay, these are our main constraints. Okay, let us see the operators. Let us see the operators. We have 15 minutes more. Okay, let's continue. SQL operations, if you want to see if it is greater than or if it's equal or less than, these are our operators. We will use them just as conditions. Okay, just as conditions we can use. If the salary is greater than 50,000, then give all the rows for these, give all the column informations for those rows. Okay. In logical operators, you can say and, for example, if the department is sales and the salary is greater than 50,000, give it to me. You can combine them with and, with or, with not. If it is not, you can use. If the department is not marketing, give it to me. It will give us others with not operator, and or not. In operator means multiple ors. It means if I use here, give me all the employees. If the department is sale, if the department is HR, if the department is IT, with or I can combine them. So instead of typing that one, if it is sales, HR, or IT, you can give all of them. Okay, this is not and operator, this will be or. You can use also between these two. If the salary is between these two, give it to me. If the salary is not between these two, you give others. You can use these logics. Order by means you can order in descending, in ascending order. You can order them. For example, just like over here, it is giving you the ID in ascending order. You see? For example, if I type here descending order, the 19 will be first one when I call it in this way. You see? It will give us in descending order. For example, if I want to get it in as here with email, in email descending order, you will see S will be first, A will be last. But if I do not use any ascending or descending, as default, it will be ascending order by email. You see, A will be first, S will be last. A, okay, this is the natural order if I do not type. But if I type ascending order, it is also the natural order. You see, the same, ascending. If you type ascending or not, it will not change anything, but you need to type descending if you want to get the reverse, means reverse of natural order. Natural order means in alphabetical, A will be first. In numerical, the less value will be first, from less to high, less to more, okay? In operator, between, we can use order by. If you like, you can also order them with multiple columns, like, for example, you will have, with the same value, 10 rows. You can also order them. You can also order them among that, between those values. The second order, you can do it. Okay, let's see the like operator. Dear friends, the like operator, we are going to use wildcards in like operator. So give me everything from employees if it is like, you know, this one. Like this means like the first character is in uppercase J, it will follow 0 or more character. For example, in table, if we have just J, it will be called. It will be retrieved. All right. If we have Jack, it will also retrieved. If we have Jane, Jane will be also retrieved. Okay. This percentage sign mean 0 or more character. This underscore means just one character. If I put here J underscore, that means second one. So if I use here N, so first character must be J, second character must be anything, third character must be N. If I have Jane, Jane will be called. If I have Jean, Jean also will be called over here. If you use here this caret, so between these two square brackets, when I use this caret just before any wildcard, for example, if I say here 0, 9, that means if it is a number. If I use caret, it means not. If it is not numbers between 0 and 9, give me others, it means. This means everything different from numbers. Okay? If I use here numbers, if it is like this, that means everything different from numbers. So this will represent, over here you see, first one will be A, second one will be anything different from B, except B. For example, AB will not be accepted here. Second character shouldn't be B. Over here, here matches any character. It will start with A. Second character can be anything here. Bracket means matches any string A, B, or C. If I use here Z, any lowercase character can be here, as I told you. Okay, let us explain also distinct clause. The SQL distinct clause is used to remove duplicate rows. You see, select distinct position from employees. So it will give us the first position about the IT, for example. The other IT positions will not be called. It will call only first position as manager or if it is multiple, every time it will return for the first one. Okay, eliminate the duplicates. For example, select listing on position. You see the query returns the first row for each distinct position. You see this one. Okay, let us see subqueries. All right, the subqueries. Dear friends, over here, the subqueries, you see, we are going to get everything from employees, but we have here a condition. It says if the salary is greater than this will return us Frank's salary, right? Whatever it is, this will return us Frank's salary. Okay, all right. We will finish SQL 6 minutes later. Okay, we will finish it 6 minutes later. Okay, dear friends, over here, as you see, this is going to give us Frank's salary. If it is, for example, 10,000, okay, if it is 10,000, so we will check. Give me everything, give me every columns from employees. If the salary is greater than 10,000, this is the subquery. So subquery must be typed between this parentheses. You can type one more subquery here if you like. For example, where the name equals, I will type something here. If the position is manager, it will give us that manager's name as subquery. Then I'm going to use this one, another subquery. You can use any subquery you like. Okay, so it is going to be a dynamic approach. So you don't need to type over here anything as hard coding. For example, if I type here 10,000, maybe Frank's salary will change. If Frank's salary will change, then also dynamically we will get every time Frank's salary. You see, this is Frank's salary, but this is not recommended. This is hard coding. Okay, so for more dynamic codes, we use aggregate functions. For example, I want to count from everything from employees. It will give us how many records are there. If I use sum salary, so that salary columns total number will return here with this sum aggregate function. Or if I use average, it will give us the average of those salary values. It is going to sum them all and divide the number of those rows. It is going to give us its average. And it will give us maximum salary, minimum salary. We can use all these aggregate functions for more dynamic codes. Okay. In subqueries, as you see, we can use them also as these aggregate functions. For example, I will get over here the all the salaries greater than minimum salary. Okay. For example, give me all these employees if their salaries are greater than maximum developer's salary. Over here, you see, list whose salary is higher than the salary of employee with the position developer. This is going to give us maximum salary of developers. If the user has greater than maximum developer's salary, it will return us that one. For example, here, if the position is Alice's position, give it to me. Okay. If the position is Alice's position, give it to me, it says. Okay, subqueries here. You can use subqueries, for example, here, maximum salaries here 80%. This is going to be maximum salaries 80%. This will be maximum salaries. We will increase the minimum salary as 30%. If I multiply it by 1.3, it is going to increase it by 30%. Okay. So with these subqueries, anything you can you can do it with this limit, with offset. Okay, you can, for example, let me show you. I got some query. I will call it. If I want to skip, for example, first three, I will use. If I want to skip first three, I will use offset. Offset 3 will skip this 3. But if I want to get only 2 columns, it will give us all the rows. Then over here, if I want to get only this first three rows, I can use limit. Okay, it will just return us this first 3. And from first 3, if I like, I can skip this 2. I can get the 3 directly. Okay, limit 5 offset 3, you can use it in this way. All right, with subqueries and offsets. Okay, let us finish with this one. Group by, dear friends, the SQL group by clauses is used to group rows that have the same values in specified columns into summary rows, such as for calculating aggregates like count, sum. Okay, let's see. For example, over here, I want to get all the positions and with average salary column. Let's see. We will get these 2 columns with their rows, these corresponding rows, but average salary. So this average salary will be based on position. For example, position A, position B, and also position A one more time, or position B one more time over here. So their average salary, this is 5, okay, and this is going to be 7. It is going to, this average salary position here, group by position, it will group the positions. You see here, it will group these positions A here, A, 5, and 7. If I divide it by 3, it will be 5 point something. It will give us this average. For B, for example, this will be 6 and 8. So we will have here B. So its average will be here 7. You see? This group by means on which values you want to group them and use their values for calculating, counting, to get the sum or average. We will group them by any row. All right, this is the group by. But if you want to use some aggregate functions after group by, for example, over here, if I want to use give me if it is greater than 5, then I will use having. So I will not get A, I will get only B. Why? Because after this group by, then I can use here some condition. Okay, if the average is greater than 5, I will say it will give me that average. Okay, dear friends, thanks for your attendance. That's it. You can also review some other topics, and for today time is up. And we will continue with JDBC for QA students. Okay, I will continue with that JDBC practice session. Okay, thank you very much.